thank you guys for coming. My name is Basil, and we're going to be doing this fireside chat with all these amazing people. I'll let them introduce themselves, but this is going to be on the future of agentic engineering. Yeah, this is the Founders Cafe. If you guys haven't been here before, it's for AngelList. So if you guys are interested in working out of here, it's a great co-working space. You guys can go to like 90.gold and fill out an application, and you'll see if you get accepted, I guess. So yeah, we can just get started. Do you guys want to introduce yourselves and like your companies? Isaac, do you want to start?
Hi, I'm Isaac. I'm one of the co-founders and serve as the CEO at Semgrep. We're building autonomous AppSec agents to replace security engineers.
Hey folks, my name is Eno, co-founder and CTO of Factory. We are building a platform that helps large enterprise businesses transform the way they build software by building an entirely autonomous software development lifecycle. So basically the tools to, one, of course, have great model agnostic software development agents, but also tools to search through the code bases and their engineering system and understand where are the gaps where agents could be helpful, and the tools to know once those agents are working, are they actually effective?
Hey folks, I'm Karan, co-founder and CTO of this company called Composio. We are building the Agentic tool execution layer. So people building agents or using agents like Cloud Code, etc., can connect their agents with different apps like Slack, Gmail, Salesforce. Using Composio, we are end-to-end agent harness. So provides like everything that you need, like authentication, just-in-time tool discovery, programmatic tool calling, all inbuilt inside Composio to connect with 1,000+ apps.
Hey everyone, my name is Calvin. I work at Cognition, where I run the forward deploy engineering org. Cognition is the company behind Devin, the AI software engineer. Excited to be here.
All right, so my first question is actually for you, Calvin. So like, what is the story with the whole like Windsurf acquisition? Because I don't know the full story here. So like whatever you can share, that'd be awesome.
Yeah, totally. I mean, I'll mention a bit share. I actually have a pretty interesting vantage point where I'm actually pretty close friends with the former co-founders of Windsurf. Like we were all in a group chat together. We worked together in the past. I also like knew the Cognition founders for a long time. So it's like all very inner circle kind of stuff. But really the story is like it all came together very, very, very short notice, right? And so like there were all these talks at Windsurf around the OpenAI acquisition, which like eventually fell through. And then they were like trying to do some, Hail Mary plays, and Google was the thing that landed. And frankly, like none of the team at Windsurf really knew until like, 24 hours before it was announced publicly. And so that landed on Friday. We actually also learned about it at the exact same time as everyone else at like 12 p.m. on Friday. And then first contact between, Scott, CEO of Cognition, and the Windsurf team was like 5 hours later. And then over the course of the next 48 hours, basically we're all locked in a room to go and figure out all the legal terms and all the stuff, and then close the acquisition on Sunday. And then it was actually very fortuitous timing because there were other people that were interested, but they all had scheduled the meetings for Monday. And so by that time already had been closed.
Awesome. So like, what were you guys looking for like from the acquisition, and what did you end up getting out of it?
Yeah, it's a really good question. I mean, I think they have a super strong team. And so that was like a really important part of it. There's actually a lot of kind of complementary, aspects to it, both from the product where, they're investing in Windsurf, which is kind of like a local agent interface. And then we were focused on Devin, which is more focused on cloud agents. And so there's a lot of kind of complementary product stuff. Our customer books are also very complementary. And so that created a ton of really interesting cross-sell opportunities, which has been kind of super beneficial for us.
Interesting. All right, so I want to change the subject a little bit. This is a talk about agentic engineering. There's a bunch of like studies out there. You probably heard of them. Basically, there is some studies saying like, well, everyone thinks that they're getting like way more productive with agentic coding tools, but in reality, when you actually measure it, they're not. Like they're actually getting less productive. Do you guys agree with that? Disagree with that? And like, what are you seeing on the ground? I guess maybe we can start with
Yeah, for sure. I think that the most interesting work here is actually done by Stanford. Has like a dev productivity group that basically looked at a bunch of different correlates with what they called like outcome-based productivity metrics. So not like lines of code or PRs, but rather things like project completion rate. And they looked at the Global 2000 and they said, when we deploy like AI tooling for software development, what can we do to predict whether or not an org was accelerating or decelerating? And what's interesting is that they also were saying like, well, what about people who stayed the same? There were no people that stayed the same. They either accelerated or decelerated. And what's interesting is that basically they looked at volume of tokens, they looked at density of power users, they looked at like spend, they looked at all of these different metrics and said like, can we predict whether or not we're accelerating or decelerating? The answer was no, you cannot. you'd also ask the question of, what if we ask their engineering leader if they know if they're accelerating or decelerating? No, they do not. And so what is the thing that actually predicted with acceleration or deceleration in outcome-based measurement? It was the quality of the code base and the linters, type checkers, and guardrails that existed inside those code bases. And so agent-ready code bases were ones that had extremely strict definitions for what good code quality looked like. And those that enforced that saw tons of acceleration. Ones that didn't saw basically like slopification. So I think that AI systems can like rapidly accelerate your software lifecycle, but it needs to be done in the right way.
Yeah. Calvin, do you have any thoughts as well? Because you guys are also building, an agentic code.
Totally. I mean, yeah, this is pretty kind of near and dear to my heart. I mean, I don't know. I feel like it's a little bit kind of like use your eyes. Like, I don't know, it's kind of bullshit to say that's not going to make you more productive. And like, we both internally and then also here at AngelList from our customers, where within the Fortune 500, there are many kind of like multi-month, multi-year projects that people are able to do with tenth of the people, tenth of the time, right? I mean, so I'll give you an example of this. So in Brazil, they basically actually went through their own version of Y2K. It's called CNPJ. It's like their version of social security numbers. And they decided, there's a law that was passed about a year ago where the format changed from numeric to alphanumeric. So you can add letters. And it basically is there's like 40, 50-year-old code bases in every single major banking and insurance companies in Brazil that just got totally screwed by this. Like all of their systems kind of stopped working overnight. And, we've worked with a lot of the top companies there and just kind of like migrating a lot of their systems. And it's like a fairly simple thing, kind of think about. It's not like the hardest problem to characterize, but literally they were slating this to go to take them, multiple man years to be able to accomplish. And they were able to do it in a couple of months, right? The one thing I'll caveat is like, I mean, obviously the progress is not entirely uniform, right? Like I think there's kind of this assumption that this technology will exist and it will just like magically diffuse into the universe. That's not really true, especially as you go into larger and more complex organizations. The reason why I think the FDE motion works so well is because there are all of these organizational and technical blockers to actually create adoption, right? And there are users who are going to be power users who really naturally understand technology, and there's going to be people who don't, right? And so the gains are not completely uniform, but they are really power law.
Karan, so like you guys are building a company, I guess, like using a lot of these agentic coding tools. So like, how are you guys building your code base to be, I guess, like ready for that and to like help you accelerate?
Yeah, I think to give you an idea, we have like 1,000 plus apps, 50,000 plus tools, and none of them are built by humans. We have like internal agentic pipeline that essentially kind of like from the start creating the developer accounts in some cases with some human involvement if needed, to finding which actions to build, to kind of like building those actions, finding dependencies, like testing for different edge cases, etc. Fully is done by the agentic pipeline. We have like literally 3-member team building agents. Same thing that like earlier incumbents would have taken probably like 100 to like 200 contractors to build that level of coverage. We have the best coverage in terms of apps and quality right now, just because we kind of like fully invested in the agentic way of building things. And that's where I think like rightly what Tino pointed, like I think the things that you need to invest in the code bases, like the guardrails, all those things that makes like agent not do mistakes, not do silly mistakes, because these agents, like the LLMs, have gotten really insanely smart. It's just they are not predictable. So you need to kind of make them confined as much as possible and let them do the magic around it.
How exactly do you confine them?
So the things are like the structure has to be good, like lints, all the kind of like best practices around. I think factory released the Agentic readiness report. I think we actually ran it on our code bases and it was pretty good in that sense. Like all the kind of like things like we use a lot of AST parsing to like the LLM not to do, like, for example, refactoring on its own, like wherever it can use some meta stuff, let them use the meta stuff, because you don't need to spend token on like if you want to do something at like all the action level, if you want to change something, that's more of a meta stuff that you want to change. So that's where like things like that, like all the general guardrails, like in Python using Graph, Astral, all the kind of like pieces around it.
Yeah.
Basically like layup for you guys.
Yeah. So I was going to go to Isaac next. What all these guys are talking about scares you? Security, I guess.
So I think there's maybe two scary things. And just to like add on to what Eno was saying earlier, the thing that I think about is not just, hey, like, does AI make existing developers more productive? AI creates more developers who we would not have traditionally thought of as developers. So like an hour ago, I was sitting down with a bunch of our executives and we were demoing, hey, what did you get done with Claude this week so far? And there's a demo from our VP of finance. There's a demo from our VP of ops. There's a demo from our head of product. And like they're shipping code. You would not think of these people as developers traditionally. And like we're seeing customers who are like, what, how come these people are showing up in the developer log? It's like, they're not developers. No, they are. For me, that's actually like probably where the security frontier is advancing in the most scary rate, right? Like you have a developer, even a junior developer, like they have some level of understanding, they're using these tools, versus someone who is really, truly vibe coding without any understanding of the underlying systems. And that's where you start to really benefit from having some security guardrails where you're like, actually, the same way that like you would use a type checker to make sure that the code types and compiles, you want some security checks to make sure that you are at least enforcing some verified security properties before things go out to production.
Claude Code and Codex, like they seem to have released their own security products. So yeah, like what do you think about those and who's going to win this?
Yeah, if you look at what they're releasing, it's actually not, at the moment at least, really designed for people writing code. It doesn't run on PRs. It doesn't run in the editor. It is more focused on the fact that the models are really, really good at kind of deep vulnerability discovery. So if you like point the model at a repository like Firefox and you give it a clear verification criteria, hey, this is what an exploit successfully working actually means. It has to produce a crash of the binary. Maybe it does something with the instruction pointer. Then you can get phenomenal results out of the models. That's actually almost a little bit of a different problem versus the like, how do you make sure that this vibe coded app is secure as it's being developed and are able to like formally verify properties about it after it ships. But I mean, the main thing for us is we don't really view ourselves as competitive with the models. Like we use them to build virtual security agents for customers. And so as they get better, we give them access to tools and proprietary data that are the kind of things that if you hired a normal human security engineer, they would have to buy those tools and data in order to do their job successfully. And the agents still need those things as well, despite their capabilities.
So, and Calvin, how do you guys build security into your products, if you do?
Yeah, totally. There's like so much that you could just, honestly, this is like a separate hour-long combo. I think that probably at a high level, the biggest things are one, you sort of need like defense in depth. And what that means is like, you really need different stages of security for different types of threat modeling. Like, for example, the most common issues are actually just developers shooting themselves in the feet. Like very rarely should you be modeling like an external threat or actor for a lot of this stuff. It's oftentimes, I just said to it, oh, could you please like remove that over there? And then it'll say like, you mean delete it permanently? And they'll be like, yeah, that's what I mean. And like, these are the types of things that, when you're building a product, that them having that issue happen is your problem to deal with. And so we have everything from like command deny lists, we have org level controls, audit logging, seam connections so that all this stuff gets exported. We have something called Droid Shield that integrates with all of the, with hooks and basically a number of different providers. There's a Semgrep extension for this, Palo Alto Networks, et cetera. So you can scan every single prompt that goes in. So basically there's all these different like customizations that enterprises have sort of like asked for and we've built up over time. And we saw also public events from other coding agents basically. And we just looked at every time that happened and we said, okay, let's make sure that never happens to us. So it's sort of like this like big list of things, but generally we also, our take is like the software development lifecycle has so many of these possible attack vectors that trying to make like Droid the thing that prevents people from doing that is not a good idea. We should instead rely on providers who already have great tooling and say the same guardrails that prevent a random dev from making a security issue are what should prevent Droid from making a security issue. So we generally recommend to our providers, hey, and this is what like agent readiness does. It will literally say, warning, you do not scan every single PR with like a SAST analyzer. You should. And then we link to Semgrep and a couple others.
Nice. Calvin?
Yeah, I mean, we work with a lot of kind of highly regulated entities, and so security is something that's very top of mind for us. And there's a lot of like fairly boring stuff around kind of like process and the process and things like that. I think the thing that's probably most relevant to this audience is like we're one of the biggest kind of dog fooders of Devin Review, which is kind of a PR review product. And in that product, we basically ensemble a lot of different models optimized for just kind of precision recall on finding and categorizing bugs and other findings. And so this is like a pretty core part of our software development lifecycle, where every PR, everything that gets created, whether it's created by Devin or a human developer, goes through this Devin review flow. And it's been incredible, honestly, in helping us kind of catch bugs before they actually get merged.
Karan, so I want to ask you a question. MCPs, I feel like a lot of people are maybe like having issues with recently. And I guess you are building a lot of MCPs. Could you just like talk about what are some of those issues that people are maybe having with MCPs, like specifically on security?
Yeah, I mean, MCP or skills for that matter, kind of like, I think it's very powerful way of giving access to your agents, like because they are very intelligent being, but if you don't control them and give a lot of access, you can go into places where like you wouldn't want to be in. So that's where I think like one of the biggest issues with MCP like people are facing is around access control, for example, like giving too much access or like malicious MCP skills where kind of like your data gets leaked, etc. So that's where I think like you need to have a very good control on the access that you give, and like you can't use any other MCP or skills out there on the web. You should have like a manage. Like I think that's where we come in. We provide you almost all the MCPs that you need in a managed fashion, rather than you have to going like any engineer in the team kind of installing random MCP that it found on GitHub.
And I don't know if I'm remembering this correctly, but you guys partnered with some company that does like a security review of your MCPs, or no? Was that somebody else?
So we do that ourselves internally, and we have partnered with a bunch of penetration testing companies too.
Okay. Isaac, like what are your thoughts on MCP and like security on them?
I think the joke when it came out was that the S in MCP stands for security or something like that. I'm actually curious for the other panelists' views on whether MCP sticks around as, opposed to skills or hooks or other like more robust ways. There is insane demand right now for doing security analysis of as the code is being generated. We will not like let the generation step proceed until we pass this specific set of checks. And so our like MCP plugin has been doubling in calls every week for the past since we released it. It's like extremely popular. That being said, one of the questions is, hey, for some of these things, especially when it comes to security, will the models just train, do reinforcement learning to like make the models generate more secure code? From the get-go. And that seems likely to be coming in the future. It's not true today. Like actually, today there's some good research that the models generate code that is less secure on average. But that hopefully changes in the future. And I'm honestly really optimistic about it because I think that, prior to models, our best hope for improving the security quality of code was put developers in a room with a whiteboard and here's your security training, which by the way is always so boring. You just want to like, but now we can train the models. So I don't know that MCP is the solution necessarily. Like I would rather see specialized models or the base models themselves just get better at generating secure code, or at least generating code that doesn't have the kind of obvious vulnerabilities. And then, there's both the elimination of obvious vulnerabilities, and then there's also things where security is a feature that you actually pay more for. And I think that's where tools like Semgrep are headed in terms of like helping you get there. Beyond what the defect reduction is, there's actually the addition of security features.
All right. So yeah, on that topic, are MCPs going to continue being used? Or for example, like Google launched their like Google Workspace CLI. Is that going to be the new thing that everyone uses? Basically giving the agents access to CLIs. Maybe Karan, do you want to go?
Yeah, for sure. I think I have at least what I believe right now, it's not going to be a unipolar world. I think like the debate somewhat started with like GitHub CLI being much better than like a lot of GitHub MCPs, etc. Like GitHub CLI was being used by all the engineers for like eternity. Like I think since I started my kind of like engineering journey, I've been using GitHub CLI. So I think it's so much in the pre-training data of the models that like it's very kind of difficult to like compare GitHub MCP, which is comparatively newer, with the GitHub CLI, where the accuracy will obviously be higher. But at the same time, like I think all the popular harnesses have been using MCP for a while, Cloud Code, Codex, etc. So now the post-training data have MCP usage also. So in terms of accuracy, I think like compared to a lot of newer CLIs, I think MCP will be pretty good. Like there are some obviously like nuanced kind of like DX issues with MCP. So like for individual purposes, I completely see that CLI will be like useful, but like an enterprise setting, because a lot of ecosystem is currently at least built around MCP, which is getting traction. So I think it will just kind of like double down, in my opinion, in enterprise setting, because MCP is much more structured, etc. It will be easier to have like the ecosystem built around it. So like it will be like a multipolar world. It won't be a unipolar where CLI is winning or just MCP is winning.
Yeah. Calvin or do you have thoughts?
Yeah, this is the fun part where we disagree. I think that my loose take is that, well, first of all, I agree that it's like not going to be 100% anything. But I think that the progressive disclosure component of skills and CLIs is sort of like the core advantage, where you say, look, do you really need to know that you can get pull request and create PR and view file, and like do you really need to know you can do all those things, or do you need to know I have access to GitHub? And if I want to then use GitHub, I can view the like available capabilities. And if I really need to read all of the arguments of how to create a PR, I can just run help on that specific CLI arg. And I think because of prompt caching, like our prompt caching ratio is like 98%. In other words, like the cost of every additional tool call in our droid is like on the order of like hundreds of tokens, right? So pennies, less, like tenths of a penny. And so the cost of basically searching and sort of discovering capabilities as the agent progresses is just so much cheaper when you have skills and CLIs. But there's also capabilities like tool search, like droid, like when you load up too many MCPs, which is something we see all the time, that used to like make your agent way worse. And now we like cache and store all of those tools, and we let droid search through them when it needs to and sort of create that progressive disclosure capability. This is like super in the weeds, but like that's the sort of thing that we have to deal with because of MCP. And so generally we're like, what if we didn't have to deal with that? And instead we just all had skills and CLIs and stuff like that. So from an enterprise perspective, you're always going to be trailing a couple of different in some places, sometimes leading though. And I think MCP enterprise actually picked up MCP really fast, and a bunch of people built them out. And I don't see that same velocity on switching over to CLI and skills. I think that the momentum of MCP is pretty strong. So it's probably here for a while, but I don't like it.
My favorite comment in this, which I can't remember where I got this from, but they were like, MCP probably ends up like XML. It's like overly complicated, informal, and it's still everywhere because, oh God.
Yeah. It makes sense. It's like straightforward.
Calvin, any thoughts or not really?
Not in particular. I think that's like the right distinction where like there are some technical differences, and I think all of those problems are pretty like you can overcome them. And I think the thing that actually matters is just like what is going to be like the compounding force in terms of adoption, which is naturally going to drive people towards it. And like that's probably the only thing that really matters. We get all the fun, dirty arguments, but like I think at the end of the day, what people use is like what actually matters.
So Isaac, you were talking about reinforcement learning being the thing that is going to get these models to be better at generating more secure code. I know like Scott has said that like RL is horrible, but it's like the best thing that we have. So could you maybe explain like what he means by that and how that relates to, I guess, generating more secure code?
Yeah, no, it's a really good question. I mean, like the thing that's really tough about RL, it's like it's very brittle. It's like very sensitive to the reward function that you learn. It's like it actually just doesn't really generalize that well. Like I think the kind of somewhat dirty truth about everything about machine learning is like as much as we talk about like does this thing generalize? Is the thing overfitting? Like yeah, RL actually it's kind of overfitting all the time. But just like if you try to bring everything in distribution, maybe it's okay, right? And so I think basically like RL is this incredibly powerful and pretty expensive tool that if you have a clear verifiable function, you can learn some incredible things. But for domains where there are like super clear verifiable functions, it becomes really tough or it requires a lot of art and judgment. Now, I think the thing that's actually super interesting about security is like, the way that a lot of people do training today is, there's some other sweet bench or some other, kind of like environments where you're trying to just like hill climb gets the goal, write some code that's going to cause these tests to pass. And I think you'll see this actually like a little bit symptomatically when you look at code that Codex or OpenAI generates generally, where you kind of see the symptoms of being over RL'd, whereas like it writes code that works, but like it looks really ugly and it just like doesn't look like what a human would look like. And that's because like the reward function is very heavily optimized to just get the test to pass, not write code that like fits within the style guides, write code that would like satisfy static analysis checker or anything like that.
So how do you make it do that?
I don't think there's any real tricks other than just like you build more environments that will basically imbue with these values into the models.
Do you think that like skills are maybe the way to do it, or no?
Yeah, I mean, I think that, so I'll put on the hat of maybe like, you can imagine like the post-training lead at OpenAI would be like, wait, I promise. And I think that like, what would they be saying? In my mind, the distribution of how to build a great RL environment is itself like a distribution that exists, right? And so if you're the labs, your bet is, look, we may not be able to necessarily just imagine a post-training environment for arbitrary tasks across knowledge work. However, once we get enough of them, we can figure out what the distribution of the workflow of creating a post-training environment for a bunch of different tasks. So it's basically like meta learning of how to build RL environments. And so like the automated researcher is sort of the like open secret goal of almost all the labs. And I think that what we've seen is especially like our harness is now capable of executing tasks over like multiple days, where if you have a sort of deterministic or validatable endpoint, you're able to basically run Droid for, an unbounded amount of time in order to solve a given problem. And so you can basically point it at like an RL problem and say, just build a harness that solves this thing. And it doesn't get you out of designing good like reward functions, but it's pretty unbelievable actually at creating these environments. And I think that generally that should be not too unsurprising, because what is OpenAI and Anthropic doing? Solving for that exact problem. So I think that their bet would be that there's like a sort of recursive self-improvement loop from post-training, which is not that you just happen to collect all of the environments, but that you collect the shape of the workflow of creating an environment. And that's the thing that unlocks sort of improvement. And most knowledge work is verifiable enough. Even like writing is like surprisingly it's always like creative writing is always used as an example. Creative writing is you can build great verifiers for a lot of things that people care about in what they consider like creative writing. And so I think that honestly all domains are like that, where it's just probably likely that it's pretty verifiable.
Have you guys played around with auto research from Andre? Like what are your thoughts on it? Anyone want to go?
Yeah. Super cool. Basically a similar concept to what we call missions in our product. Basically, just Ralph Wiggum's as well is a common term that people have used, if you guys have ever heard of that. But you just want to say like, look, the goal is achieve this outcome. And you want to set off agents that just keep going, experiment, build hypotheses, test it. And on like micro problems, like building a micro version of ChatGPT, you can do that pretty well. On hard problems like build AGI, doesn't do you any help. But clearly this paradigm of set off agents towards outcomes and allocate a budget of compute to these outcome-driven systems is closer and closer to what the world is going towards.
So I want to change the topic a little bit. So like Cognition, you guys launched a suite like 1.5, I think. Like you're training your own model versus Factory, you guys are specifically like, I don't think you're training your own model.
Yeah.
At least yet. First of all, like, why are you training your own model versus just being kind of like a multi-agent orchestrator, I guess?
Well, or both,
yeah.
Right? It's like I think the whole story of Cognition is we'll use whatever is the latest greatest. So that means using frontier models and as well kind of training our own. And I think there's a couple actually pretty important reasons for this. Like one is we work in kind of like highly regulated environments. So the ability to kind of host our own models is actually quite important. The others is like we've actually figured out that, as we kind of move into a world where there's kind of intelligence saturation, right? It's like, is a model that has, 120 IQ, like that much worse than a model that has 160 IQ on software engineering tasks? Like probably not that much of a meaningful difference. So there's the other things in terms of like developer experience that matter a lot. And one of them is speed, right? And so the ability for us to train kind of small and more nimble models and host them ourselves also means we can also like raise the number of TPSs that we serve out. For example, SUI 1.5 generally runs about 15x faster than frontier models. And so if the thing that you're thinking about in terms of developer experience and speed, then it's a much better model in that sense.
So, like, why aren't you training your own model?
Yeah, for sure. I think that building a model, I guess, and there's two sides to it. Pre-training, you can do like continued pre-training. You can also do the post-training, and you can take a model. And I think it's also like very early on this sort of stuff. So to some extent, like if you take a model that is not allowed because of regulatory and then you post-train on it, does that make it like allowed? Sort of, I think that there's a lot of open questions about that don't get asked that often. And I think that generally our view is that you sort of want to do this at effectively the last possible moment where it makes sense to do it. Like when maybe that saturation moment happens where like a 150 IQ model is just not that different for most tasks that matter from like a 180 IQ model. I think that we get things like Tinker and all these other systems to basically make programmatic training just so significantly easier. The cost continues to fall of basically post-training and fine-tuning these models. And right now, when you post-train or fine-tune a model, you sort of you put a bunch of money and CapEx basically into building this system, talent, right? And people, and they build this thing, and then Gemini Flash 1.5 comes out the next day, and then it's instantly better than like the model. And I think that what we found is that our harness continues to be the best performant harness across like multiple models. And generally, we're sort of looking for that moment where when we use our harness with like the sort of equivalent on the Pareto frontier of cost or quality, do we start seeing like non-frontier models get outperformed? But right now, like even the model, like a model got announced earlier today, right? That is actually not that much better than Minimax M2.7 in our harness. And so I think that in terms of cost or quality. And so I think that it's just sort of like this moment where we're like, okay, definitely at some point, it probably makes sense to train a model, but at some arbitrary point in the future, it's probably cost goes down to like near zero, in which case then it's like an economics thing. But I think if you're trying to push the frontier right now, it's like super unclear if that's possible without a massive capex that we don't feel we need because basically we outperform without it.
Okay. Hizek?
I was kind of interested that neither of you mentioned distillation, which I feel like is the proven cheapest way to train a model without training a model. So I don't know if you had any comments on that as a mechanism specifically, but
yeah, well, that's what I mean in like cheaper. Like basically like it eventually just becomes like the shape of intelligence might just be a fixed shape. And as we get significantly better models, most people think of it as like building like a thing, but instead we may be discovering a shape of intelligence. And distillation kind of proves that. Is basically as models get better, the shape of what AI systems that are sufficiently capable starts to become more refined. And once you know what that shape looks like, take a photo and you're good to go. And like basically someone just footed a massive bill to discover that shape for you. And then you just say, thanks, I'll take that. It's way less clear than the valuations of companies that take part in this would indicate that this is like true or untrue. And I think that that's like a huge risk if you believe that that's like true or untrue. It probably like dictates your worldview in many ways of markets today.
Could you guys just define distillation? So basically like Opus comes out with a new model, and then like some, I don't know, Chinese company, maybe they ask it a bunch of questions, get the output, and then train their own model on that. Is that basically it? Or
yeah, exactly. There's this like great, if this is like also like too in the weeds, like please let me know. But like there's this great paper called the Platonic Representation Hypothesis that just said, let me look at a bunch of different models that are trained in totally different algorithms with totally different data. And as you just scale the amount of data, the embedding space of the models starts to look more similar and more similar and more similar, indicating that as you just add more and more data to the models, they're just converging on one shape. And if that hypothesis continues to remain true, not only profound for us, because it's irrespective of the algorithm, which means it doesn't matter if it's a transformer or a diffusion model. It might not matter what the algorithm that's actually running is. It might just matter what your training data input looks like. And the shape of the basically like underlying reality is fixed. And so all models in many ways are trying to approximate the same distribution of data. And so if you get a model that's extremely good at basically approximating like sufficiently capable data, that just might be like very easy to replicate by just looking at that distribution and sampling. And so far, the Chinese labs are saying that's pretty much exactly how it works, and it works really well. So,
And for those, I assume most people know this, but Anthropic actually published publicly that DeepSeek was distilled from like one of their models. Like they have, kind of very damning evidence to that effect. And I was hosting this conversation with the former OpenAI CISO, and he was like, never in human history has there been an IP asset that was so expensive to create, whose value has decayed so quickly, right? Because like, who wants to use GPT-3 now? Nobody.
Yeah. I mean, crazy comment coming from the companies that literally took all of the IP of humanity without permission and then use that to build their models. But like, who's to say?
So like Isaac, I think you mentioned that in security, you want to use like hybrid systems. You don't want to necessarily just use a totally probabilistic model to generate things. Could you talk about that? Like, why do you want to use a hybrid system? I think that was a year ago, I think, about when you said that. So yeah, like how has that evolved?
Yeah, I mean, if you look at, going back to, again, the way that people are finding vulnerabilities with models, they are generally, the models are too happy to please in terms of, so I had a binary that I reversed years ago that was very obscure. And I was like, I know this thing is full of security vulnerabilities. I gave it to Opus 4.6 and I was like, go find the vulnerabilities. Immediately, it's like, oh my God, I've definitely found a vulnerability, right? Like, it keeps backing off. It's like, well, there is actually a check for that. But this is definitely vulnerable going down this path. And there's some good research put out there by security researchers that are basically like, yeah, it finds vulnerabilities, but with a very high false positive rate. So combining that though with a verifier that's like, well, now your job is to actually construct an exploit for that vulnerability and then like make it run. Suddenly the like signal to noise ratio, as long as you can satisfy those conditions, is phenomenally high. And so if you to the points that were made earlier, it's just like software engineering. As long as you can define the like validation criteria with a deterministic program, and maybe the model even writes that program, you can suddenly be phenomenally productive. But I feel like what you're actually seeing is this kind of like trade-off between GPU time and CPU time. And in the security community, there are actually some people who are talking about that in terms of like export regulations on GPUs. How effective are they actually at preventing people from like finding crazy vulnerabilities? But like the models are seriously insanely good now at finding security vulnerabilities. Like they have to be run in the appropriate harness. But like we are not ready for the like wave of vulnerabilities that is coming as a result.
Have you seen any like crazy uses to attack companies recently, or like within the last year since LLMs have come out, or nothing really crazy?
I can't talk about a lot of them, but I will tell you that a friend of mine who used to work at NSA called me up on Monday and he was like, dude, I'm using Opus 4.6 and I found a like massive like internet-wide systemic vulnerability, and like he works at a big company, so it's going to go through their like responsible disclosure process. But the thing that I really enjoyed was he was like, it just wasn't that hard. So yeah.
Okay. Fair. All right. So I want to change the topic a little bit again. How is using the coding models different for when someone's just working on like a side project on their own versus when you're working with an enterprise, right? I'm assuming it's going to be very different. You're working on a giant code base versus a small one. I know you guys like focus a lot on enterprise. So maybe you want to start like what's different about me just vibe coding a side project and you working at Facebook using, droids or whatever. Like what's different?
Yeah, totally. I mean, ideally, our job is to make that less and less different over time. But process is by far the biggest thing. Like what our forward deployed engineers and our solution engineers do is they basically just try to help enable these agents, which is actually just insanely fun, right? Because you have these unbelievably powerful systems that generally, when just pointed in the right direction, can do a lot of really amazing things for your average enterprise. And I think that a lot of what it is sort of co-discovering these use cases, because a priori, we know that the coding agent can write code, it can write tests, it can do code review, it can do incident response. But the nuance of those problems in every different company is so wide and so deep that a lot of really the work is sort of learning about these insane decisions that were made 15 years ago from this company that now pain them every day, and sort of saying, how do we untangle this? And in particular, we happen to have like these portals of infinite knowledge that can execute arbitrary code and have infinite knowledge of Bash and all these other important skills. How do we point those in a guarded and secure and sort of like ultimately, guardrailed direction towards solving these problems for an enterprise? And so, you're dancing around way more restrictions, you're dancing around way more like workflow constraints, you're dancing around way more complicated code. But ultimately, the task of saying, let me find problem, let me point agent at problem, and really clarity of thought in describing what the problem that you want solved, and almost treating it like a problem with a validation criteria, a definition, and a solution. That if you really want to vibe code well, you can do that too. And you'll make these like insanely awesome projects because you're unencumbered by legacy. But probably that also COBOL sucks. So that's another big one that just is annoying. You guys also do a lot of enterprise.
Yeah,
We do. I think like the simplest way I would describe it is like, there's a big difference between writing code de novo versus working in large companies where frankly, you're actually not writing that much new code. A lot of what you're doing is like mining for precedent within an existing code base, which is something actually the models are like, okay, but not great at. So we've invested a lot in code-based intelligence, which is kind of like the practice of like context engineering, figuring out all of the right systems you need to integrate it into to be able to build the right context, to be able to mine for that precedent. And then therefore write code that is not only just like works, but also like matches the style guidelines of a company, matches like all the historical precedent, et cetera, et cetera, et cetera.
So what do your forward deployment engineers do?
Yeah, that's a good question. Also, actually, I think for listeners to the answer that you was saying, which is kind of like this co-discovering on these cases, right? And so I think there's kind of this art of, we would work with these large enterprises, and you want to be able to kind of discover their top problems and figure out how to unblock all the technical and organizational issues to be able to go and make agents successful within that context. And so it's kind of this like very interesting problem that mixes, technical and commercial, because you're trying to navigate what are kind of their own fiefdoms. Just to give you an example, Citibank has 45,000 developers, right? So that's 45,000 people that are doing a lot of software engineering. They need to go learn how to use a product, need to use it correctly. And so figuring out how to do that is a big challenge.
Yeah, Karan, how are you guys using agents internally?
So yeah, as I mentioned, I think like all our integrations are firstly fully built by agents. So like the whole agentic pipeline and kind of like harness around it, which is like testing of these kind of like actions, which is like figuring out dependencies. Okay, this action depends on that. Everything is done essentially by agents. So kind of that's one. And like we also have built, I think like what people are doing, what we are seeing all around is like Ramp has built their own internal software engineering agent. Stripe has built in Minions. We also have something built internally. And I think the power of that is kind of like it can build itself. It has like, and kind of that's very powerful because like you don't have to rely on, you can kind of like whatever your needs are specific to your company, like whatever like your developers are like want, you can get that very, very quickly, but by asking it itself to kind of build it. Then internally we have like this thing called agent orchestrator. I think like Devin released like Devin can control Devin's type of a thing where we are using that for a while now. So we have like agent orchestrator where like people internally you like have like 20-30 parallel Claude codes and codexes running, and the main orchestrator agent is actually kind of like orchestrating across all of them and kind of like figuring out what's going on in specific. They can ask questions to the orchestrator of what's happening in this particular thread, etc., to experiment all across. Every developer like in our company now has like a work OS, which is like an open claw, which manages the orchestrator essentially. So they can work, like I can work on my Slack, Telegram, everywhere and kind of like issue, kind of start some project that I want to do.
How do you guys think about the cost, like the token cost for all your developers?
Yeah, I just look at it at the end of the month and try to calm my nerves.
Okay, so you're kind of like, okay, well, we need to use these, so we don't really care about the cost. Like, how do your customers, like the enterprise customers, do they care about token cost really, or not really? Because yeah, let's say you're working with Citibank, they have 45,000 developers. That sounds like it's very expensive. Do they care?
Are still there?
They're all still there. I mean, yeah, it's definitely expensive. It's something that's pretty top of mind with enterprises where I think, a lot in Silicon Valley is just like, let's just push the limit in terms of, kind of the frontier. But like, most big organizations care about price performance, not just performance in absolute terms. And so we have a lot of pretty robust kind of cost controls and ways to tune price performance for the individual customer. And it's like a pretty big part of the selling proposition because, like I said, I mean, yeah, they're not going to foot a couple $1 million bill.
Is that another reason why you're training your own models? I think that's why you...
Sure, right. It's like, again, it's like you want to be able to optimize not just absolute performance, but also just price performance across the curve.
Yeah. Okay. I guess you don't really think about that because you're just you're just working with like Claude Code, like Codex, like all these like open source models, or do you think about that?
Yeah, we don't wrap around agents, we wrap around the models. So it's a similar concept where we're able to leverage, there's sort of like this like Pareto efficient frontier of cost and quality that all the models, and actually one of our most popular features is our auto model router that basically takes advantage of the fact that we have a sense of basically what models for the given cost optimize for different tasks. This has been super popular at a lot of the banks that we're working with, like just being able to say like we will automatically route to this model versus that model. Like if you look at Claude Code's built-in code review that they released on GitHub, the cost per review is $20. on average, which is crazy because that's a huge amount of spend. And that's also the true API cost of the non-Claude Max Plan subsidized version. And so for us, like our belief is, look, if you have a code review that runs on every single PR for 45,000 developers, you simply just need that to be a much cheaper model than the daily driver of the, like, let's say, architect who's about to design a mission critical system should be using Opus 4.6 to plan every single like aspect of the problem. And so I think increasingly you can actually think of the models as being effectively a commodity, right? Where there's an efficient price that needs to be searched through intelligence. And if you think about times in history in which businesses would commoditize their complement, so to speak, Microsoft did this with PC, AWS did this with basically compute hardware. I think that generally the role of companies like us is to be an aggregator, right? We look through the models and we say, it's kind of expensive for you to know the difference between Sonnet, Opus, GPT 5.4, Minimax. And ultimately, if we can just like solve that problem for you, that alone is a unique like value proposition for a lot of businesses. So I think it's actually like a good like fundamental reason why we add value, regardless of how good the models get.
Isaac, I don't think I've asked you, like, do your developers now use like Claude Code, Codex, Droids, like internally?
Oh, yeah. We are heavy Claude Code and also Cursor users.
And Droid soon, right? And Devin. Yeah. So what guardrails do you have on your developers using those tools? Because obviously you guys are building a security company. So yeah, how do you think about that? Also, you're basically routing your code through Claude Code. And I feel like a lot of companies are, or through like Opus or Codex. And I feel like a lot of companies are not okay with that. Why are you guys okay with that?
So we don't route customer code through those models without having, DPAs or other things signed. And so we're comfortable with doing that with our code for the same reason. Essentially, they're not training off of it. In general, I actually think that being super sensitive about your code is more of a legacy company thing, right? If our code base got leaked, I'm not actually really that concerned about like the security properties of it. Like pretty much all of it is web facing anyways. So it gets pen tested as well as, of course, being statically analyzed. There's defense in depth when it comes to that. What was the follow-on to that question, or did I get everything you asked?
I guess I do have a follow-on question. Why do legacy companies care about their code being like going through like Opus or Codex? I think you've mentioned before, like there is certain types of vulnerabilities that brings up. So could you talk about that?
I guess I would say legacy companies are just afraid of what they don't know. And to start with, they have no idea what's in their legacy code bases, right? Like the people who built it are gone or dead. No one has any idea. So like most obvious thing would be like hard-coded credentials and secrets are sitting in there. There are probably also like embarrassing security vulnerabilities, kind of God knows what else. And then when it comes to the models themselves, honestly, I used to like work on a reverse engineering tool, and there has never been a binary more difficult to reverse than a like foundation model with its weights. Like our ability to statically analyze and reverse and tell you like, oh, this weight does that, basically doesn't exist. Like the people doing the best job of this are Anthropic, and they're literally, going in and like turning this one up and that one down and being like, oh, like seems like this correlates to that. It's much more like neuroscience than it is anything approaching engineering, right? Which is kind of wild. And so I think that freaks out legacy businesses as well. They're like, yeah, we have no idea what's in our code base or what's that thing that it's going into is actually doing.
Yeah. I think you've also mentioned before that like when you have a giant company with 45,000 developers, well, what could happen is one of the developers maybe like, open sources some part of a code base on GitHub, and then the model companies will train on that, and that will basically poison the models. And so that could be bad for security.
Yeah. And so props to Anthropic, who actually did this great research where they were like, oh yeah, the number of samples required to poison a model appears to be independent of the model size. So it doesn't matter if you're 100 million or 7 billion parameter model, you need about 250 samples in a corpus to poison something. And so there's an old paper in computer security called Reflections on Trusting Trust, which is basically how can you trust that your compiler is actually compiling the code and doesn't have a backdoor that's introducing a security vulnerability into the code? Like you have to trust the compiler as well as the source code. And there's kind of something similar with the models where, imagine you like went on GitHub and you knew that like your target company had this header file that always looks like, copyright, blah, blah, blah. And you just like made something such that whenever the model saw that, it just is more likely to create this specific kind of security vulnerability. Like that is actually totally possible today. And no one really knows how to assess the risks of it. So rational or not, that's, one of the things that like a legacy enterprise is concerned about.
Yeah. That makes sense.
Or a non-legacy enterprise, to be honest.
Yeah. So I want to talk about harnesses because you guys have mentioned harnesses a lot. Could you define harness? And then what makes a good harness to you?
Yeah, I mean, I think that the term harness is definitely like not a term of art right now. It's just sort of like a way to refer to a system that takes LLMs and sort of like orchestrates their calls in some form or fashion in order to achieve more autonomous or more intelligent decision making. Like I would say that broadly, the definition of like an agent in our mind was a system that exhibited like decision making, planning, and environmental awareness of any kind. And I think that like probably that applies to a harness as well. Is just like it can plan, it can execute decisions, and it has some awareness of the environment it operates in. That could be many different things. And that feels like good enough. It's sort of like defining life. Like fire might be life if you take a thermodynamic approach. I don't think that it really needs to have like a super concrete definition, but I don't know, maybe actually others disagree.
Yeah, I mean, like essentially, I think like harness in my mind is essentially kind of like putting in context engineering plus like what the model spits, what you do with it. So kind of like half of it is like what you give the model. Like in our case, we provide some like meta tools where like the model can discover different tools like progressive disclosure, like sandbox around it where the model can write code, and like we provide all the things around auth, etc. around it so that it can kind of write code on top of Gmail, Slack, etc. So yeah, I think like the verification around it to make sure it's achieving the outcome.
Yeah, Kelvin?
Don't know anything super clever to add, but it's just like LLMs on a very basic level, like take text in and text out, and they're just like doing completions. Like harnesses is like the whole system around that to get like useful output.
So like what's unique about Devin's harness?
Yeah, no, it's a good question. I mean, this could be like a really, really long conversation, and it gets into a lot of some of like the secret sauce stuff. But I think a lot of it is around how to use different models for the right use cases and give them the right accesses and have the right mechanisms to, deeply understand where models are good and where they're bad, and like how to, fix that basically.
Why are companies like Ramp building their own harnesses? Why are they not just using somebody else's?
Yeah, no, I mean, it's a good question. I mean, it's actually kind of interesting. Like, I know Rahul, who's the engineer who worked this at Ramp, and like, honestly, on a very basic level, I think he kind of needed a passion project. That's my honest take. And so he just wanted to work on something kind of fun and motivating for him. But I think like, I don't think Ramp is doing this because they think they have any like secret alpha. I think to kind of Karan's point is just like, they think they can just build something that works for them. And that's good enough for them.
Yeah. Karan, like, why are you guys building your own? Like, what unique features do you need that like open source ones don't have?
Yeah, I think it is more around like very, very minute things that people kind of like want. And like, for example, when we started, like some of the kind of providers didn't have a cron, and we were like, we need a cron. And so we just like build it and like we call it internally Zen, and Zen built it for ourselves. In our kind of like integration pipeline, there are a lot of like nuances around what we want to do. So there, the harness has to be somewhat different, like figuring out dependencies across different apps, etc. I think one of the things that like, if we own the harness, and maybe I think Devin, Roy, both of like kind of would be doing that, but like, I think the interesting part is like continual learning of sorts, some sort of continual learning element that like, I think if we own it, we can do it much better, like learning from the session traces, etc. Over time. I think that's the reason that we did it ourselves.
So kind of like learning your company's coding style, things like that.
Yeah, and like what is failing. So like kind of, okay, if there's a type of review, there's like skills that created automatically. So one of the things that we do is like Zen creates like after every execution run, it kind of like looks through the session, creates some learning and patterns of what worked, what didn't work, and kind of like adds it to a rack store, which kind of it can reference later. In some cases, it creates skills. In some cases, it just improves the system overall.
I think droids do that, right? Or no?
Yeah, droids have a big part of like continuous learning, but I think that like it totally makes sense to me. I think that like one of our investors likes to tell this story every time he comes into our office, because we have this back room, which was clearly designed to be like a server rack, and it's maybe a little bit like a quarter of the size of this room. Every time he walks in, I think he just forgets he's told us the story before, but he walks in and he's like, crazy story about this. Let me tell you about the first time we built our own like server rack. And so he goes on this long story about like walking through San Francisco, putting the server rack together. There was a memorable part of the story is that an engineer saw them like sort of pushing this server rack through the city and was like, what are you guys doing? And then like went in and then learned about the company and they hired him and he ended up being one of their better engineers. You know, the cloud exists. And I just think that like at this point, like we're in the building your own server rack era where it might even make sense to build your own harness right now. But generally the types of optimizations we're doing on our harness, we like don't see anything even close to that in any of the public available harnesses. And I think that's fine because honestly, a lot of that stuff probably doesn't matter that much right now. But it definitely starts to compound when the volume of tokens that are going through. Like we generally think that probably like token spend right now is will probably like 5 to 10x by the end of the year. And then it'll probably keep 5 to 10xing for at least 2 to 3 more years. And that's why things like cost kind of don't matter to people. Things like your harness kind of don't matter. But in like, by the time that we look and reflect on this period in like a couple of years, it'll be like very obvious that you want a commercially extremely capable harness because the spend, the capabilities, the quality will just be so different between what you can build yourself and what's available at scale. And so I actually think it's a good exercise because all the companies we know that build their own harnesses know how to use these things way better than everybody else. So like it's strictly good for the team. Because when they do pick up a commercial harness, like I think they'll probably be some of the best users of those harnesses. So I'm actually like vaguely pro, but also enterprises do this and every single one we've seen has failed. So
want to clarify. I think like the main harness like internally we use is Cloud Code or Codex. So kind of like we have option around it. So we are just building scaffolding around it. And one of the reasons I remembered we did it was like we tried some, like we have a multi-repo setup and like a bunch of like the background agents were not like that good. Maybe Droid is, I don't know, but like we're not that good at multi-repo. And we just did it like where, okay, it's like we have Cloud Code. We'll just build it, the scaffolding around it.
Yeah. Isaac, do you guys have your own harness or are you guys thinking about it? Why aren't you guys doing it?
I mean, it depends on your definition of harness. I think for the definitions that are used here, definitely yes, right? Like, but what we're really trying to do is, you know, you have a agent, which in our world is kind of like a virtual security engineer. Okay, what are the things that they need access to in order to do their job effectively? Because you can't just take a like mono repo at a customer, give it to Claude and say, find all the vulnerabilities. Like it actually just, it will find things, most of them will be wrong and it will take forever and be super expensive. And so you have to have this kind of like breakdown into, okay, like how do we decompose that? Like figure out when we're going to call these tools. We think about it as actually more like workflows. Like these are the workflows that a security engineer would go through. And we don't call them forward deployed engineers because my co-founders were from Palantir and that has a like very specific meaning in their mind. But we do send engineers on site to customers to basically help them build these workflows out in a way that, you know, actually maximizes the kind of security efficacy. So it's like almost like building a security harness per customer a little bit.
Interesting. You know, you've mentioned that agents are basically bottlenecked by the ability for them to validate their own work. Like, what do you mean by that? Could you talk about that?
Yeah, I think it's a lot of the stuff that we were talking about earlier of just like when an agent operates in a code base, you can say to the agent, like, please never commit in this part of the code base. Or you can just have a rule that prevents the agent from ever doing that deterministically. And so generally, I think that there are actually an innumerable number of ways in which you can control the way that anyone at your company operates inside of the code base. And if you're like, we actually open sourced all of our like lint rules. If you actually read through how we do things, we say like files have to follow very specific patterns. Folders can only contain certain types of these like file pattern based structures. The code itself needs to be structured, enums and enum files, classes and class files, types and type files. We have AST parsers that look at certain code paths and prevent agents from parsing. And generally, like, I mean, this just happened to us. We had a big bug that was preventing like an update, which is the worst kind of bug. And it's because there's this code path that we just like sort of underestimated was more complex than we thought. And the immediate solution from the engineer was not to go fix that bug. They wrote an AST parser, well, Droid wrote an AST parser that basically lints that section of the code base to prevent additional code from being added into that code path. And like that sort of work is sort of meta engineering. And I think increasingly what we're seeing from people is like, what percentage of the team today of your company directly manipulates the software? probably like 90 to 95% of your engineering team does that. And then 5%, you might call them dev platform today, or you might call them security, and you might call them product managers. They modify the product engineering system that builds your product. And I think that probably by the end of even this year, more and more of your team will move from directly manipulating the software to manipulating the product engineering system that builds your software. And that sort of like movement up the ladder of abstraction means that you have to think about things like linters and type checkers and code formatters. And that's almost the way that which we enforce structure at scale in very complex code bases.
Calvin, how do you guys validate that Devin, I guess, is not going off the rails or anything?
Yeah, I mean, I think this is like the beauty of software engineering, which is like there's these like very nice in terms of checkers to know whether your code is like correct. Like you can lint it, you can compile it, you can run unit tests, you can run integration tests, you can run end-to-end tests. And like this is the reason why I think if you look at the progress of AI, software tends to be the discipline that's most at the forefront, because there are all these natural kind of checks to make sure that as agents kind of progress in the world, you kind of like keep them on the right track.
So all of this stuff that we're talking about, it feels kind of anecdotal, but I'm sure you guys are running evals, right? You guys are running, like you actually have numbers on, hey, like, I don't know, all this stuff, you basically have numbers around it. How do you guys run evals internally?
Yeah, it's a good question. I mean, look, we have just like a pretty large data set, and ultimately what you actually care about, right, is you want your data set to match the distribution of your actual real world usage, right? And so we basically, a lot of it is not taken from customers because of legal reasons, but like inspired by things that we see by our customers. And we can start to collect this very important data set and get a really good idea of not just like, oh, model X is better than Y, but on all these different axes, right? And so we can actually get a sense of maybe this model is better at tool calling, is better at introspection, or is better at, debugging. And so you get a much better and deeper, richer sense of what different models excel at.
Could you maybe go over like a simple example of what that would look like?
Probably can.
Okay. Anyone, can you go over like a simple example of how you guys run evals?
Yeah. Basically, so for us, we primarily focus on online evaluations, which means we look at the performance of Droid in real customers' hands. And primarily that's why we have like a self-service, like even offering is to, and it's very clear when you sign up, basically what we can do is we can do aggregated anonymized behavioral analysis on top of users. And so Claude Code actually has an awesome blog on this. We built a very similar system where you can completely strip all identifying information and not even store the code or the session data. And what you can do is you can use the harness to basically classify and identify patterns, trends, and behavior locally, and then aggregate that up at the top level so that you never send any important information over the air. This is super interesting because what you can then do is you can say, what are the types of patterns and behaviors, and actually have the harness self-identify at runtime when it's failing and when it's doing well, and classify and aggregate that upwards to say, I'm actually doing a very bad job on this user's behavior, and I think it's because there's a broken MCP, and send that up over the air, right? And so this is sort of cool because what it lets you do is it lets you preserve your user's privacy while also getting data in the real world about the frictions that exist inside of your harness. We also do a bunch of offline evals where we just partner with large companies and say to them, like, can we just build like a massive eval on your data that you host? And then we just run the harness in your environment. And you send us the results of the eval. And that helps us do like real world imitated stuff. The nice thing is that it just bleeds into like all the public evals, and that like, all the public evals are totally gamified. But we actually have a rule where we're not allowed to like look at things like terminal bench, SWE-bench, et cetera. We just have a repo that runs the eval, and we just happen to be like topping it basically every single time. Because I think that the distribution of these like larger enterprises is like strictly greater than these like basically gamified evals.
Okay. So I want to change the subject a little bit again. I think, Isaac, you guys started Semgrep in like 2017. So that was before any of these LLMs. What did your teams look like then? And how have your teams been changing in structure now? And then we can give it over to you guys because your company started, given LLM. So we can talk about that.
Yeah. Well, I mean, when we started, we were just an open source project. There was like really no commercial offering at all for the first several years. So we didn't really like start scaling out the team until about 4 years ago. And I think the like biggest thing that has changed is, it used to be that in order to build like really great program analysis, you needed like people with PhDs in program analysis. And you still do need that. But it turns out, I think the models have just shifted the balance quite a bit, where actually like iteration speed matters almost more than anything else. Because the models are trained on a lot of classical program analysis algorithms. And I think one of the things that like really surprised me was, you guys are probably familiar with the halting problem, right? Like, given this program, will this program halt or will it run forever? And although this is like, generally undecidable, there's benchmarks to like see how well you can do and like, writing a program to do this. And one of the things that really amazed me was LLMs are now scoring second in the world on benchmarks for this. And then if you look at how they're doing it, it's literally this train of thought where it's like, well, then I is set to 0 and then it's checked. And then it's like, but wait. And it goes back and just like it keeps saying, but wait, and it has this kind of English textual representation of what's going on, and that is actually kind of very similar. I mean, the halting problem is a form of program analysis, and so like the way that our teams have thought about even like what models are capable of with things that we thought would have to require data flow and things like that has totally changed over the past year.
So do you now just hire fewer security researchers?
No, security researchers actually more, because the combination of understanding, hey, like this is what program analysis can tell me, this is what inference off of the LLM can do for me, is very much like you want a security researcher who has done this to find vulnerabilities. Because for us, like to answer your eval question, it's all about 0 days that we found at the customers. Like, and sometimes we find things that were the customers like, hey, we have to end this meeting early because that's an incident for us. And so we're going to go fix it right now. Unfortunately, a lot of the like public cyber benchmarks are just not that valuable. So it's all very much online with customers.
Calvin, you guys have a pretty unique perspective because you're working with a lot of enterprises. So like, are you having to do a lot of change management? Like, how are those teams changing now that they're using agents?
Yeah, no, for sure. I mean, I think this is actually like one of the big topics on the minds of CIOs in the Fortune 500s, which is, I think they're very aware that the world is changing and that their organization is going to change with them. And a lot of actually what they're seeking by working with Cognition is just kind of guidance on how those teams and their organizations will evolve as AI software gets rolled out. I think like some super tactical examples, like we have a customer where the average kind of like pod or team size was around 7. And as, kind of Devin has progressed with the organization, they actually reduced it to around 3. But the throughput of each of these pods as they measure has actually increased, right? And so there's both some benefits in terms of, okay, well, you're doing more with less, but they actually found that because the teams were much more nimble, right? And because there's kind of less coordination costs, they're also actually just more creative and more effective and actually doing more useful things, not just more.
Karan, so you guys started the company, I'm assuming, knowing that you're going to be using agents. So like, how did you structure your teams to take advantage of that? Was that like a conscious decision or did it just sort of happen?
I think like things are changing so fast right now. Personally, I and the team has to evolve every few months to kind of optimize how we can maximally use AI and accelerate at the same time. So I don't think it's like a straightforward single answer. I think like every 2 to 3 months, like December was definitely a shift where like the models just became like a notch above and we could see like what was possible earlier was not possible. So it was like on like a lot of like in cases like on me and some part of the team to kind of evangelize across the team to use some of that stuff. And that's where I think like the whole like motion around Zen and a bunch of stuff started internally. So I think the answer is like I think we have to evolve much faster as these models are getting faster. But I agree. I think like the size of the team that used to be like it should be much smaller team. I think that's better. Like generally we have like for each project or kind of like sub thing, like we have like a 3-member team in most cases because that like feels like the right number where most of the work is still done by agents and like humans are just for like brainstorming and kind of figuring out the solutions.
So is the type of engineer just changing? Like are you seeing that like the engineers you're hiring now are maybe in a past life PMs or are they just engineers as they used to be? They're just like their role is just changing.
I think like even before AI, I think Linear had a pretty good blog around like product engineering where most of their engineers are like product engineers. So I think that has become even more true in the AI era because a lot of like core engineering is definitely being done by models. And then to certain extent, most of the engineers are actually talking to customers, like actually going deep into like some of the tactical product bets that we want to make and figuring that out and like being like making those decisions rather rather than just doing engineering. And some some folks in the team are obviously dedicated to making sure everybody is moving to like the 10x level, kind of like said, which is like making sure the infra around these models, the repo is kind of well suited for agents to work the best.
How about you, So like, is the composition of an engineer changing? Like based on your experience, your teams, what are you seeing?
Yeah, I mean, I think that the answer is a little different for us versus like some of our customers. Like what we have operated on basically since inception is the idea of like, you ship your org chart. And so our product surfaces basically map exactly to pods, and we use the pod model. So they're sort of flexible. And in the early days, the benefit is that like, as you're searching through like the solution space towards like what you think your customers will get the most value out of, you can sort of adapt and adjust pods around basically products and bets that you're making. And then as those start to solidify, you get people who just start to consistently more like work together, and they gain complementary skill sets, and then they take over the product surfaces that become more like reliably that have like durable value add to your customers. And so what that has led to is like 3 to 5 people per pod for us. And I think that the composition has always let like most of the team are either folks who were in like DeepMind, UberML, like worked in AI research in some form or fashion, or they were product engineers or founding engineers at like earlier stage companies, or they were founders. And so almost everybody sort of is just pretty agentic out of the box. And I think that more broadly for like very large organizations that we work with, I think that what we've seen is that the general sort of pattern is that I think a lot of how organizations scaled their engineering org was via structure. So introducing sort of like, hey, this is just a very clear role with a very clear set of responsibilities. And so like these people are responsible for that. And what we've sort of worked with these organizations on is saying, look, if you're able to figure out which of these structured roles can dissolve into each other, then you can actually sort of like more responsibly group together complementary skill sets and transition people into roles where they're actually able to add value. Because generally what we've seen is that companies who have not fully saturated their market strictly benefit from additional engineers given our capabilities. Like basically Droids just unlock so much more potential TAM for your company. It's generally a bad idea to like let go of them because they just become, let's say it's like $1 million of revenue per employee. We can just make you $1.5 to $2 million per employee. So why would you remove that? They're like a huge value center.
So my final question is, if you had a younger sibling in college right now and they wanted to study computer science, would you recommend that to them or no?
Absolutely, yes. Like, I don't know. In my mind, like there are some like wild scenarios where AGI takes over and like no one really has a job and we live in fully luxuriated, or what's the word? Fully automated luxury space communism. Yes. Or disaster ensues, whatever. I think like from a like very technical perspective, it's kind of like if you were learning to write assembly and compilers came out, oh my God, like there are all these people now who are like Java programmers. You're like, no, you're not a real programmer, right? And you still benefit though from like knowing how to write assembly, like the fundamentals of computer science, like there's always benefit to like knowing how the whole stack works. And even though we're like going up like now some really powerful layers of abstraction, there's still going to be tremendous leverage to understanding how it works. So I would say yes.
Yeah, I'm biased. I would say you should study cognitive science, neuroscience, and computer science. Like the intersection that like a lot of schools do that. They have like SimSys, like cognitive science, etc. I think that probably gets you much further in the world. But that's probably the only bend to it is basically like computer science with extra spice about brains. Because I think that probably gives you the mental models you need to work with these systems.
Yeah, I think like something on the similar line, like you need to have like basically working with assembly gives you that clarity on what the systems are doing. So that plus kind of like hard sciences, kind of like amalgamation of both, I think is where I would bet on.
Yeah, 100%. I mean, I'm slightly biased because I love computer science, but I think it's just like the way that it teaches you kind of thinking abstractions, like these are always kind of perpetual skill sets.
We'll open it up to audience questions if you guys have any.
So first of all, great presentation. It was very comprehensive and you covered all elements of it. I have a question related to large enterprises, right? how to increase the adoption of AI in large enterprises. They have major 5 problems, right? First is legacy infrastructure. Second is the scattered big volume of data. Data is not classified. And third is integration of these systems. Fourth is security, which you covered a lot. And fifth is customers, external customers, their data, audit, governance, all frameworks, intellectual property. How your customers who are enterprises are approaching this, because as if I have a CIO security hat, they'll be scared. If I have a CFO hat, I will say, I'm giving you money, but I'm not seeing ROIs. So I think you covered about some studies in Stanford about ROIs. But how are your enterprise customers adopting this and increasing the user adoption of this, and also training their workforce along with them? Thank you.
Yeah, that's a great question. Do you work in a large enterprise?
I used to work in a large enterprise. Then I moved into a private equity-backed software company.
Okay, cool. Well, I can give you a great pitch about this later as well. But I think that the like TLDR here is like, I mean, I think our fastest deployment was we went 0 to 10,000 engineers in 2.5 months. And so the speed of deployment with us is just very, very fast. And the way that we enable that is a local first architecture. And basically, like the individual sort of program that you install, Droid, is effectively a single binary. It can run on any OS, any VM. It can run in any IDE in the terminal. If you do want to run it in the cloud, you can, but you don't need to go and deploy all this heavy machinery, infrastructure, Kubernetes, all this other stuff. So we basically just kind of come in and we say, do you validate that this thing works? Okay, great. Boom. Now put a link in your Teams channel. And now everybody basically can install it. And then there's a lot of enablement along the way, but I think that an intuitive product is actually one where the average person can basically open it up and be presented with clear enough happy paths such that they're able to uncover sort of what's possible. And then the product itself can do a lot of the work, but ultimately partnering on things like enablement, so trainings, workshops, et cetera. And I think that most enterprises end up being surprised. I mean, all of the engineers at these large companies are on Twitter. They're like on Twitter, they're on LinkedIn, they're reading through, they are itching to get their hands on a fully capable agentic software development system. And then when you present one to them that just like works, and in a way such that like it can operate in their VPC, it can operate with data governance, with security, they're just pumped to get access to it. So speed of deployment, I think, is important. And then there's a lot of like at the like middle management and above, a lot of like, okay, once you get this, let's help you measure why is it failing in these areas? Why is it working in these? What is the ROI and impact? And I mean, that's like a whole, again, we should just talk.
Blue jacket. Yeah. I think so.
So the question was, how can you improve your agents? Because a lot of people are building agents and maybe they just don't necessarily know how to improve their agents continuously.
Secret, just kidding. I think that okay, so 2 things. The first is the answer that you shouldn't do, which is decompile our binary and find out. But the second thing that you can do is you can go and read a blog post that we have called Signals, which actually outlines in far greater detail than I'll do justice in this. But the TLDR is have the agent run a sub-process every time it finishes its work. Ideally, do not charge your customers for that because that's your compute, right? And so run that process. Don't offload it on your customers. I mean, that's just our take. And then process with a very lightweight LLM a couple of different things that matter to you. And then you can basically classify a bunch of these different things and return a structured data payload and like let your users turn that off also if they want to.
I was interested in your previous cloud agents, GTM. I think you both guys started with that. And now we're kind of like moving more into this like hybrid between some tasks are cloud, some tasks are local. First of all, what was the barrier there? I imagine like setting up those like large code bases to like run locally and so on. There's so many things that are preventing that from happening smoothly. So what's the GTM strategy there? And second is like, how are you seeing now activity local versus cloud in the product?
I don't know if you want to.
kickstart that. Sure. Yeah, no, I mean, I think ultimately it's kind of like the maturity curve in terms of your like agentic adoption journey, right? And so like generally you want to start local because it's easy to set up. And then as you kind of scale up, you run into all these issues, get work trees or parallels and all these things. And then cloud agents become the natural form factor, right? And so like our ability to kind of progress people through that journey is actually a really critical part of getting them from zero to the eventual kind of end state, which is in our opinion is Devin, right? And so I think that kind of informs our go-to-market motion, because when we go through that journey with customers, you want to guide them in that journey as well.
Yeah, I mean, I totally agree that it's sort of like an adoption curve. And some people like to start like super aggro and like, I want to parallelize 100 agents at once in the cloud. And I think that generally we try to sort of talk to people and say like, well, what are you actually trying to accomplish? And the nice thing is like, because Droid can run on any OS, any VM, basically anywhere, when it runs on your local machine, that's the same agent that runs in the cloud, is the same agent that runs in your CI/CD pipeline. And so all of the customizations, all of the org controls, everything is basically exactly the same. And so our customers basically don't even notice almost the transition from local to cloud. It only just enables a couple of nice things like sandboxing and some security stuff. Split between local versus in terms of like number of agent inferences, or it's probably like I actually don't know this off the top of my head, like 75-25 local cloud is, and I would expect that to increase towards cloud.
So thanks for the talk, guys. We have a consensus.
All right, the question is, you guys are at the frontier of the agentic economy. So what is the future of the agentic economy?
I'm not an economist or a sociologist. I will say from a security perspective, virtual agents, virtual employees have many of the same issues that humans have. They can be confused. They could be prompt injected. They can be potentially bribed. So the security implications of it are all not going away. And in fact, they're probably getting a lot worse, because it means that, for instance, if you look at text being produced online, we are in a golden age of the ability to create propaganda that, people would have dreamed of 20 years ago.
Yeah, so I did a quick search saying your company actually doing the pre-component security. Is that right?
Yes.
So after deployment, so all this kind of whatever happening after deployment, so you're not touching that up.
No.
All right. Maybe a last question.
When it comes to prompting, what are the key differences between a vibe coder and a 10x engineer?
I think this one's just like planning ahead of time, but I think it's like the most obvious difference. It's like models and generally LLMs perform much better if you have like a clear description of the goal, and then also all the checks that basically you want, the agent to complete when you go through the tasks, right? So the point I was saying earlier about having the right kind of like testing pyramid around linting, the compiling, the unit tests, integration tests, all of these things help a lot.
I guess I have a follow-up on that. What would you say is the difference between spec-based development and plan-based development? I think maybe, because you've said that before.
I was going to say that's a deep cut. Yeah, I think specification, we generally think of specifications as being like what to build and how to validate it, versus plans are sort of like how to build it. And it's sort of like almost all the tools have like plan mode built in. And if you actually read through what it does, it's like almost 50%, then I'll do this, then I'll do that, then I'll do that. It's like sort of like a procedural guide. And our view is that planning should almost happen outside of this like human verifiable artifact. And like the human should read a specification of exactly the outcomes or sort of like what they want built, and a set of validate or like invariants basically of like what should definitely be the outcome and how should I validate that is correct or not. And generally we've seen that improves performance. But I think that your question about like what makes the difference between those, I really feel like you should not have to know the difference between those two things. Like generally, if we are building a product where you have to like learn this like arcane whispering in order to make it work, I think that's like bad. And in like, we really want to get to this world where your intent is just like made clear, whether that's you being able to be competent at speaking the language of these systems, or if it's these systems are competent at eliciting from you the exact outcome that you actually want. So generally, like I'm very anti-prompt engineering and anti-prompting, because I mean, not because I think it doesn't work. It clearly works, but that I feel like it's a I still think even our product is like bad at this. Like it feels like it should just be great at extracting your intent. And that's just really hard to do.
Karan or Calvin, do you guys view spec-based development as different from plan-based? And like, how do you guys build that into your products? I guess like not Karan, but maybe like Calvin. And then maybe Karan, you could talk about how you guys have your developers do one or the other.
Yeah, I mean, I think it's like some semantic difference, kind of like imperative versus like declarative, right? But so I think it matters, right? In the same ways that like in programming languages, you have like imperative versus declarative paradigms. I think that matters in the margins. I guess it's short.
Do you prefer one or the other?
I think basically the thing that actually really matters is just like, does it work? And I think you can probably make both work.
I guess which one works better?
I think you can make both work, basically. I just don't think it's like that different.
Karan, what do you think?
Yeah,
And then I think we'll have to stop there.
Yeah, kind of like I think no specific ways in which we kind of like, I think for different problems and use cases, like both works, but I think at the end, what matters is like your system around it.
Okay, cool. Well, those are all the questions we had time for. Thank you for coming. Let's give a round of applause. And that's it. Thank you for coming.
If you want to join us, let me know at factory.ai and we are aggressively recruiting for so
Hey, are you going to get a Spec by chance?
Yes.
Yeah.